So I want to talk about something that we deal with every single day at our work. You go to work, you want to get your work done, obviously, and then about 2 p.m., you start thinking, what am I actually working on? Because you just got dragged into all that mess, came out of nowhere, and we have to deal with. That's what I want to talk about today is, well, my experiences. That's what I want to share with you. When I was a kid, a little kid, I used to tell a lot of scary stories. I'm grown up today. I just talk about programming. That's even more scary. And that's what I want to talk about for the next about 40 minutes with you, is my scary experiences. I'm a consultant. I go around the world. I work with different teams who develop software, and I work with their engineers, developers, programmers, testers, architects, business analysts, and I learn from experiences that they go through, and I want to talk about things I've observed in general. Well, as they say, Heraclitus said, the only constant is change. So we deal with change all the time. And we take requirements, and before even we could implement it, we got to change what we are building. And that really brings up the question about agile development. So what does it really mean to be agile? And it really comes down to our ability to adapt, ability to change. And that's really what agile development is. But I do have to say, one of my most, I would say, unpopular tweets ever was something I didn't expect really to be retweeted so many times, but I have a corrupt mind. Almost anytime, anything I do, I keep thinking of programming in the back of my head, software development in the back of my head. And I was with my family one day. We were having lunch, and this is a few years ago. My children next to me, and my boys were sitting next to me. My wife was across the table. We were talking about something during lunch, and suddenly I took my phone out, and I was texting with my two children, curious what Dad was texting. And they looked at it, and I immediately texted it. I was about to hit the send button when my son said, "Dad, no, you shouldn't tweet such things." But of course, as a parent, you know your only mission in life is to embarrass your children. And anytime they tell you not to do something, you want to do it. So I hit the send button, and my son is like, "Oh my gosh, I cannot believe Dad tweeted this." And within seconds, there were retweets and literally thousands of retweets within a minute, and I was really kind of scared that this is happening. Well, the tweet I'm referring to is this one. I wanted to think about software development. And I said, I've set a wedding date. I've not asked her out yet. How software projects are managed. So this is unfortunately the way our industry is. Because how many times have you seen this? The boss comes to you and says, here's the project, here's the deadline, here's what we're going to do. And they set all the things before, and then they tell you, oh, by the way, we are agile. Where is there to be agile when you have decided all the things up front? So one of the key things about agile development is adaptive planning. And if you're not willing to adapt your plan, there is no point in talking about agility or being agile or doing agile development. So I want to think about what really makes this hard for us to adapt. What really makes it hard for us to change and to be able to respond to change when our customers come back asking for changes. And I would say the answer to that question is that complexity really makes it hard to adapt to change. There are several things that makes it hard, but this is one of the things. So complexity really makes it hard for us to adapt to change. And unfortunately, though, that system design is complicated by nature. Let's not be naive about it. We are not doing simplistic things for a living. If you're developing an application for taxation, I can't think of anything more complex than dealing with the stupid tax laws around the world. And if you're developing a tax software, you have the greatest sympathy I have. If you're building an accounting application or an airline reservation system or a hotel booking system or anything non-trivial you build, there's got a lot of complication in it. So we build systems that are complicated. That's what we do for a living. But unfortunately, though, what is complicated becomes really, really hard when we bring in complexity. So there's a difference between being complicated and being complex. Complicated is the nature of the world we live in. But complexity is a self-inflicted wound. We cause it on ourselves. And when we make things really complex, it becomes hard for us to really manage over time. So I would say we add complexity to what is already complicated. And I would say we are the victims of our own complexity. And one of the things I fear the most, honestly, is the unnecessary complexity. There are two kinds of complexities we have to deal with every single day. One of them is called the inherent complexity. The inherent complexity comes from the problem domain. The complexities of your domain, your tax laws, your medical records, bookkeeping, your reservation systems, your pricing model, all of those are the inherent complexities. But unfortunately, the other type of complexity is the accidental complexity. Accidental complexity, unfortunately, comes from the solution that you choose. And if you have multiple solutions, some solutions may be more complicated, some solutions may be simple. But if we don't take the simple solution, but go towards the complexity, that it drowns us into that mess and becomes really hard for us to respond to change and to be able to develop system and deliver value. So I want to ask the question, what makes software systems really complex? Well, I'm sure there are several things that make it complex, but I want to identify things that I have seen personally in my client projects and my own projects where I've seen evidences of complexity. So these are purely from my experiences, and I'm sure you would be able to relate to some of these, and I'm sure you will be able to log other things maybe I don't mention as well. But I want to start listing a few things that I've seen to be really making things complex. The first one I would argue is too many moving parts. If your system has too many moving parts, that's part of complexity. And if you're thinking, gosh, microservices, sure, that's one of those problems itself, isn't it? When everyone in the world wakes up one morning and thinks that they have to build microservices, there's got to be something wrong, isn't it? But that's part of complexity we bring in as well. And complexity is great if we have a reason to deal with it. But if we brought it in because of infatuation, that can be really hard. But let's talk about moving parts in this case, other than things like architectural moving parts. As Leslie Lamport said, a distributed system is one in which the failure of a computer you didn't even know existed can render your own computer unusable. So this often happens in systems where you don't even know where the failure is, and you're like, why can't I use the system because something somewhere is broken? So having too many parts can make things really, really hard. But this reminds me of an experience with a company that I consulted with about 10 years ago. And I remember the day I was kind of so scared because their president called out and said, come on over, we need to talk. And I'm sitting in front of their C-level executives. And he has just issued an order to stop all sales of their product. And I'm thinking, oh my goodness, if you are a company and you told your people you cannot sell anymore. And I'm like nervous sitting in there listening to him. And I have been through their company. I know their engineers. I've looked at their code. And the reason he issued this request is when I started working with them about a year ago, I had a chance to look at their code. And I'm not even exaggerating when I say this. In their code, when they had been in business for 10 years prior to that. And they wanted to really, really be able to do what their customers wanted to do. And as a result, when I was looking at their code, I was shocked because the code literally said, if the client equal to the name of the client, do this work. If the client is this client, do this work. Because they wanted to customize their product for every single client. And I was talking to their engineer, and I asked them, how does your program work? And they proudly told me, our program is configurable. And I said, what can you configure? And they said, everything. And when they said everything, I thought they were kidding. But they were honestly serious. You can configure everything. But they got to the point where you can configure everything that when they land a new deal, their company spends 8 months to deploy the product because they need to go in and configure everything. And so this was excessive amount of configuration file. There was unnecessary complexity and components, too many layers. how do you really make any change to this particular software? And the entire configuration was in XML. And of course, everyone here has used XML, right? And when you use XML, I realized configuration in XML is configuration from hell. Because when you start doing XML document, you know, if you never used XML, what do you think? The first day you look at XML, you say, that's cool. And then about the second day, you think, that's weird. And about the third day, you say, touching XML should be given to people in the prison. Nobody in the free world should be forced to do it. And that's how you begin to feel. It's not machine, it's machine readable, not human touchable. And unfortunately, this company had everything in XML. And I came to realization, XML is like human. It's really cute when it's small, and it gets annoying as it gets bigger. And that's kind of the problem with XML configuration, and they got drawn into this XML configuration mess, and they just couldn't deal with it. And this company lost all its capability to respond to change, and they got delayed and delayed and delayed, lost their reputation, and finally the president said, enough of this. Until we re-engineer the whole product, we're not going to sell anything. Well, just for you to know, the company is doing extremely well today. But they had to really go through such an enormous re-engineering before they could actually come back to being able to succeed. And that was horrible. And how did we get into that mess? Because somebody thought this was a great idea. And that's something to really think about. So it became brittle, it became error-prone, it became hard to deploy, it became hard to test, it became hard to reason with the code. So this is one of the things I often tell my developers. If you find it hard during development, it's only going to get worse during deployment. This is an early warning sign. As a developer, if you feel like, gosh, this is really hard to test my product during development. It's hard to deploy during development. It's hard to maintain it in development. It's only going to get worse when you put it in production. That's an early warning sign. So look around. If you have a lot of moving parts, it's a time to refactor that and reduce that complexity. That can help a lot. The next one is, I would say, things that add to complexity are what I would like to call as invisible change. And I will mention to you one experience. I'm still bitter about it, and I really wish I had not done this. So a team came to me and said, hey, you know C++? I said, oh, yes, I know C++ really well. I've used it for about 15 years. And then they said, you know Scala? I said, yeah, I know Scala really well. And they said, great. We got a C++ code. We want to convert it to Scala. Can you help us? I should have said no. But I said, sure, I'll be happy to. And they sent me the C++ code. Now remember, I know C++. And I start reading this code, and I'm reading it and reading it and reading it, and I don't understand. Because the code is doing something, but I don't know how it's doing it. And out of desperation, I said, okay, I got to really understand why this code is even working. Because I have this code, and I put a debugger. This is you reach the lowest point in your life when you have to depend on the debugger to know what the code is doing. I put the debugger, and I'm on a line, and this object doesn't have anything. And I step over a get function, and the object is completely populated. I'm thinking, it's a get function. Why would it populate an object? I don't understand. Then I step into the code. It's not doing anything useful. Then I step in, and I step in. I'm like, I don't even know, maybe 7, 8 levels below. And I'm still thinking, how does this code even work? And the point when you feel absolutely stupid, because you're looking at this and you're like, why don't I understand? I thought I was an intelligent person, but I can't understand this code. And you feel really, really low. And that's when I came to this realization. There are two kinds of code that truly frustrate me. The first kind of code that frustrates me is the one that won't work. I'm like, why doesn't this damn code work? But the one that frustrates me even more is the one that works but shouldn't. And I'm like, why? Why does this code even work? It's not supposed to. And that's when you know that you have absolute disrespect for the human who's going to read that code. Because the person who wrote it said, I don't care. I'm going to just do this wherever I want to do it. And these, I call them as invisible changes. When you make invisible changes in code, it deprives the human of the dignity when they read the code. Because they don't have a clue why this code is working and can be really, really hard to maintain. So finally, of course, I figured out what the code was doing, wrote the code in Scala, sent them the code and said, here is the solution, and by the way, never ever email me back. I never want this experience again because that was horrible. So don't sneak around and change state. This is one of the tenets I would like to follow, because the more state change you make, the harder it becomes to maintain the code in the long run. And the problem with this is it's a very heavy cognitive load. You're trying to understand the code, and state changes make it all the more difficult to understand the code. So the next thing I will mention here, in addition to too many moving parts, invisible changes, is what I would call as uncontrolled mutability. And if you ask me, I've been programming for about 35 years now, and if you ask me what is the thing I do different today than I did earlier, I will tell you really minimizing state and minimizing state change. The reason you want to minimize state change is, I would say mutability needs company. It often hangs around with bugs. So the more you mutate, the more error-prone your code is. A guy came to my desk and said, I've got this code I wrote. It doesn't work. Can you help me? So this is the code he wrote, but it doesn't work. And in all fairness, it was not a long piece of code. It was about 10 lines long. And I'm like surprised. 10 lines, you should be able to know what the code is doing. And I read the code top to down, and I said, if this is the input, this should be the output. He said, I know, right? But it's not. And I'm like looking at it like, gosh, why wouldn't it give the right result? So we're just literally looking through every line talking, and they said, wait, on line 7, did you really mean to change the input given to you? And he looked at me and said, you know what? I'm stupid. And he walks away. And I'm like, whoa, you just mutated a variable and you don't realize you did, and your mind cannot relate to it. So every time I see excessive mutation, I see bugs lurking in code that becomes hard to understand. And I'm going to go to the extent to say that state transition causes brain damage. You know, one of the theories I have developed over time, how many times have you heard people say, programmers are weird, right? Or they say programmers are not sociable. You heard that, right? I was at the optometrist. She was looking into my eyes, examining my eyes. And then she said, Venkat, what do you do for a living? I said, I'm a programmer. And then a few minutes later, she said, Venkat, what do you do for a living? I said, I told you already, I'm a programmer. And she said, yes, you did, but I just wanted to hear again and confirm, because you look almost normal. And I'm like, what do you mean? I look almost normal. And that's when I figured out, we are not antisocial. We're not. Because when I'm sitting in an airplane, I always sit in the window seat. And if you ever see me in the airplane, I'll be the quietest person in the world. I'll be sitting there. I just traveled here, and literally I sat in the flight. My wonderful wife is traveling with me, and she always rolls her eyes. We both sit down. As soon as my butt hit my seat, I flipped open the laptop, I started working, and the flight attendant said, you just sat down. I'm like, yes, ma'am. And you're already working. What's wrong with you? And my wife is like, yeah, you know what this is about, right? That's the way I'm wired. And I got work to do, I got code to write, I got books to write. But the minute I know the person next to me is a programmer, it changes everything. We got so much to talk about, from garbage collection to memory leaks to concurrency. Will be a riot on the plane. So my theory is programmers are not antisocial. We are social with the right kind of people. That's what it really is. But one of the reasons why we look antisocial is we got so much to process in our head. Everything is up here. We are thinking about stuff constantly, isn't it? So here is I'm sure you know this already. I'm preaching to the choir. You're sitting in the room and you're working, and what are you doing? You are thinking, this object here has this data. It sends the data to this object. That's sending it to here. That's making a call back. And now this is over here. And you built all this in your head. And as you're processing this and about to write the next line of code, somebody opens the door and says, have you had lunch? And you're like, what? Have you had lunch? And you're just staring at them. And they're like, you're weird. And they walk away. And you're like, here we go again. Because all that model is on the floor. And you got to put this back in your mind and build a state. And you're about to make the call, somebody says, hey, have you had a cup of tea? It's like, get out. I need to focus on this because I need to think. This is why we don't like people. Because we got all this built up in our mind, and they just come back and throw this all, asking silly questions like, have you had food? Who wants food? I've got code to work with. This really, I'll tell you, the best money I ever spent in my life, was I took my wife to the Social Network movie. You may not be able to hear this. I'll read it to you, what this says. And here's what is happening. So this guy, Sean Parker, is going to show up. So he says, somebody at the door, go take a look at it. So he's walking to the door, and of course, Sean Parker walks in, and he wants to just, hang out with the team. So he comes in and says, hey, I'm Sean Parker. He says, nope, don't bother. And he says, oh, no, don't talk to him. He is wired. And the minute he says he's wired, literally my wife jumped out of the seat and said, oh my gosh. I'm like, whoa, what happened? She said, I get it. I said, what happened? I know why you're weird. And I said, why is it? And she said, no, you're not weird, you're wired. I said, take my money, this is awesome. Because finally she's like, I know why you don't respond when I ask questions. So the following week I was home in the kitchen writing code, and my son came to ask a question. And she said, Dad, I've got a question. And my wife said, don't talk to Dad right now, he's wired. I'm like, yes. So my argument is that happiness is when the world understands programmers. Because then they know we're not wired, we're not weird, we're just wired. And this is the life we live in. Because all that complexity we got to bring into our heads and work with it all day. The next problem I've seen often is lack of cohesion in code. So what is cohesion? Cohesion is where like things are together and unlike things are apart. When we make the code not cohesive, we got to hunt around to places where to change. This becomes very expensive to make the change in the code. So lack of cohesion is another thing we can address if we want to decrease complexity in code. So of course the question is, why should we care about it? And the reason is we want to reduce the frequency of change to the code, and we can do that by addressing cohesion quite a bit. So in a way, we talk about modularized code, where every component can focus on one particular detail and becomes easy to build upon that without becoming overly complex. So we talked about a few things, but one thing I will mention is excessive dependencies. If you truly ask me, what is one thing I fear? I fear dependencies. Now, I'll share with you one experience I had with a company. They were developing code with JavaScript. And I was sitting next to this developer, and he said, we quit running all these test cases. I said, oh my gosh, you quit running the test cases. Why? Oh, we upgraded a few libraries, and things were not compatible, so we quit running these test cases. And I said, you upgraded some libraries. How many libraries do you have? And without much emotion, he said, oh, we have about 150 libraries, I think. 150 libraries for this product? You don't need that many. Knowing that I don't believe, he opened the build file and showed me. Sure enough, there were 150 or more dependencies, libraries. And I said, why are you using all these libraries? But what I really like about him is he was very honest. I said, why are you using all these libraries? He said, because we found them. That's a really good answer, isn't it? You found them. You are out to lunch with the team. You're having a good lunch with your team. And while having lunch, in the next table, somebody from another company is sitting and having lunch. And one of your developers overhears what they are saying. And you turn to your team and said, did you hear that? What is it? They're using JavaScript. Yeah? And they're using this library we never heard about. 2 hours later, it's in your production. Right? How could we not use that library that others are using? This is one of the problems we face. And I looked at my own life over the past 30 years, and I realized I used to program in C++, VB before then. Then I programmed in C# for my living. Then I programmed with Ruby on Rails and Python and Java and so on and so forth. And I realized a consistent theme across these things. I've had one hell of a programming career, from DLL hell to jar hell, through assembly hell, through NPM hell. You may say, what's next? We live in this thing called module hell right now in Java. But of these things, I would say there's one hell that's special, and that is NPM hell. I was on the flight the other day. Honestly, everything was going fine. I had my laptop closed, and the captain said, folks, we are at the cruising altitude. Everything is going fine. I've turned on the seat belt. All I did innocently was open my laptop, connected to the Wi-Fi, and I just did npm install. Turbulence immediately. He's like, ding, sorry folks, I spoke too early. I'm like, sorry, I shut the computer, never to open it again in the flight. So that's really, really horrible. But I was mentioning this to a friend of mine, and he said, we don't have a problem with dependency. I said, you don't? He said, yeah, we develop a Java application. We never have problem with dependency. I said, really? How is that? And he said, because we use Maven, he said. I had to tell him the bad news. You don't use Maven. Maven uses you. So essentially the problem is we get plagued with dependencies all the time. So what do we do about it? Dependencies are hard to maintain. They become obsolete really quickly and become really incompatible. If you ask me, one thing I resist over and over and over is bringing in new dependencies. I want to thoroughly evaluate it. Evaluate the cost of using it, but evaluate the cost of removing it as well. This brings us to another problem I see a lot is technology infatuation. Imagine the person who has a resume where there are 200 technologies listed. I always ask the person, do you do all these? And they say proudly yes. I'm like, you are fired. I don't want you on my team. Why? Because I want people to solve my problems, not just increase complexity by bringing everything they can imagine. Let me say it differently. We need to spend time learning new things. There's no doubt about it. But my argument is, if the only things you learn are the only things you use, that's trouble. I want to learn about 100 times more things than I ever put in production. Because as a professional, I need to learn continuously, but also have the wisdom of not bringing things in when I don't really need them. There's a contrast between the two. Some people are forced to bring things in because that's the only chance they get to use it. And unfortunately, we have to ask the question, is this the right choice for technology? Think about things like reversibility, how easy it is to reverse out of a decision and undo the changes if you decide to use it. What is the cost of doing it? If something is very reversible, take a good decision to use it. If not, put more effort in deciding. For example, the difference between libraries and framework. Libraries are much less scary than frameworks. When you use a library, especially if you reduce your surface area of dependency on the library, you can easily reverse it out. Frameworks grow around you. It's incredibly difficult to change your framework compared to changing a library. So I often say the use of a library is easier to reverse than the framework to reverse. And I would say using a library is like dating. Using a framework is like entering into marriage. You don't want to do that too lightly. Your date doesn't go well, you say, I tried, that's not a good match. You get married, it can be really expensive deal to reverse it. Dating is more reversible than marriages are mostly. Same way with libraries versus framework, take a little bit more effort deciding when it's the right thing to do and when you should avoid it. So essentially the complexities of dependencies are something we should be very careful about. But when I was a young developer, I remember having to use dependencies, but when I wanted to bring in dependencies and use it, that involved ordering it, waiting for, I'm not kidding with you when I say this, for a tape drive to arrive. And I spent my youth installing the tape drive and spinning the tape drive, and that's how we installed software. And my children even find this hard to believe, that you could actually use tape drive to install software. When there was a tape drive between you and the software you want to use, you didn't use that many of them back then. But today, you can just download the software before you blink your eyes, and you can integrate it into the code. So the cost of getting software in is cheap, but the cost of getting software out is expensive. It's a reverse in time. When I was a young developer, it was expensive to integrate software. Now it's expensive to disintegrate software. It takes more time and money to remove a poor dependency you brought in. And often this is called the resume-driven development, because people want to use something not because they need it. I was talking to a developer and talking about technology. He leaned over to me and said, "I have a request for you, Venkat." I said, "What is it?" "Please, could you don't come to talk to my boss about this." And I told him, "You don't need this technology. You can do something simple. Please don't talk to my boss about it." I said, "Why not?" Because we convinced him, you cannot build the code without this. If he ever knows it, he'll fire me. So why did you use it then? Because I want to get that on my resume, right? So resume-driven development is a very common reason people bring in technology, not a good one. But I say this with a broken heart, but I'll share with you the story of what I would like to call as a tale of infatuation. I was working on a project. This was 2004, and this was February 2004, and this was a time of recession in the US. Not many people had jobs. And I was happy to be a consultant on a project. And as I was working through this, they said, "We want to really have more help. We want to hire people." So they were interviewing people, and I was part of the interview process. We interviewed a lot of people. None of them really worked out. One person we interviewed, I'm like, "My gosh, this guy is amazing. Let's hire him." So the VP of R&D came to me and said, "What do you think of this guy?" I said, "Amazing. Hire him first. Don't waste your time. Just go hire him right now." And then he said, "What do you think of the framework he's been developing?" I said, "That's the best framework I've ever seen. It's amazing. Don't waste your time. Go hire him." He said, yeah, one more question. "What do you think of us using the framework?" I said, "Whoa, hang on. Sit down. Let's talk about it. Please don't do this. Don't talk to him about his framework. We got work to do. Let's work on this project. Let's finish it. We're going to deploy in 6 months." But did you notice how beautiful that framework is? I said, "It doesn't matter how beautiful it is. We don't need it right now." But Venkat, did you realize when he demoed that persistent, distributed messaging library he has built? I said, "You never used those words in one sentence ever before with me. You don't need it. But wouldn't it be so cool to use it?" I said, "Look, your eyes are dilated. You don't want to do this. Please don't. Tell him you want to hire him. Don't talk about the library framework he's been developing." A week goes by, Wednesday afternoon, I remember clearly, 3 o'clock. I'm sitting and coding. He comes over, sits on my table, and says, "Venkat, I've got news for you." "Yeah, what is it?" "Well, we extended the offer, and he agreed to join." I leaned back in my chair and said, "I can't tell you how happy I truly am. I'm selfish. I want to learn everything possible from him. He's amazing. And I'm looking forward to working with him. This is going to be great. We'll get this done. We'll release it in 6 months. Awesome. Oh, by the way." Yeah? As part of the hiring contract, we agreed to use this framework. I said, "Please tell me you just said this to make me angry. You just want to see my reaction." "No, this is true." "Well, I just resigned then." He said, "I told my boss this is exactly what's going to happen." I said, "Hey, at least I'm predictable. You got to give me credit for that." I immediately got up, put my stuff together, and said, "Do me a favor. If you have anything else going on in the company, let me know. I'd like to come and work with you guys. This is not the project for me. I can tell you this is not going to end up well. I don't want my hands on it. So I'm out." Very rare, one of those days I showed up home on time, or ahead of time. My wife looked at me and said, "You're home early." "Yeah, I quit." And she said, "What does it mean you quit?" "It means I don't have a job." And she said, "Not exactly. There's dishes to clean." Like, "No problem." And I went and did that for a couple of weeks, found another job, moved on. And 18 months later, I'm not kidding, 18 months later, 2005, my phone rings. And he calls me and says, hey, Venkat, hey, long time no see, how are you doing? Go ahead and say it. I'm sorry, say what? Go ahead and say it. I told you so. Oh my gosh, what happened? And a year and a half later, they had not still released their product. Why? Because they wanted to make the framework fit to what they need when they did not need the framework at all in the first place. Breaks my heart even today. And the entire team failed because they were infatuated about a technology. So don't build what you can download, but don't download or buy or build what you really do not need. This is one of the things that really I get afraid of when people are infatuated and want to start using things. But when it comes to complexity, I talked about accidental complexity. Low-level concurrency is an accidental complexity. So when it comes to low-level concurrency, we can think about a lot of problems, and we looked at this problem and said we can solve this using a pool of threads. Now we have a pool of problems to deal with. And usually, the more concurrency we bring in, the harder it is to maintain the code. Part of the problem really is the following. If you look at this piece of code for a second, I have a little example of a code where I have a main, and it sleeps for 2 seconds. It says setting done to true, and sets done to true. Okay, no problem, done is set to true. But notice it is done is false, starts a thread, sleeps for 2 seconds, done is true. What does the thread do? The thread says, I'm going to go through a while loop, keep counting, but if the done is true, I will quit the loop. So very simple code, right? Most programmers who do concurrent programming, unfortunately, haven't taken the time to understand the Java memory model. And without knowing about the Java memory model, we can never get the code correct. So this code looks innocent, right? You have false, done is false. You eventually set done to true. And in the middle, you have a thread that keeps checking for done and quits if the done is true. So I go here to run the code right now. And when I run the code, it says in main, running. 2 seconds later, it says setting the done to true. But notice the program has not quit. Should wait a little longer. You can keep waiting. It will never, ever end. What's going on? Well, you're wondering that. All I'm going to do is simply say try thread.sleep 0 to add insult to injury. An exception, in this case, let's say EX. So I'm not even sleeping. I set the sleep to 0. That's all I did. Now I go back and run the same exact code with that one change, and 2 seconds later, the program exited. You can ask even experienced developers, why does the code behave different when you set the sleep to 0? And the answer comes down to most people don't understand the Java memory model. Without understanding the Java memory model, how could you get this right? So here's a way to think about it. Raise your hand if you write assembly code. Really? Not a single person in the room? Usually there's one person who raises the hand. Oh, there you are. Can you raise again, please? Thank you. Thank you for doing it so the rest of us don't have to. And that's exactly what I say about concurrency also. I say that the concurrency in Java is the assembly language for programmers. Most developers shouldn't do it. And those who do it have to be respected because they spend all their human power to solve that one problem and try to get this right. Here's the reason why it's a mess. To get concurrency right, everything has to be right. For concurrency to be wrong, just one thing has to be wrong. That's a very tall order, and it's incredibly difficult to get it right. As a key design skill we need to develop is the ability to discern between accidental complexity and inherent complexity. And concurrency, to me, is an accidental complexity. Similarly, we all have programmed in imperative style. Imperative style code is backed with accidental complexity. It makes it hard to understand, hard to maintain the code. Declarative style keeps our focus and not have us distracted because we're not focused on the how. That's another reason I favor declarative and functional programming. But one thing I will mention here, is this idea of really entwinement. We do this a lot in code without even realizing. Not just us, even the best programmers in the world suffer this consequence. But I want to show you an example of this just to illustrate the point. And even the folks behind the Java language, unfortunately, really did not realize how terrible this could be and landed into this particular problem. So let's talk about this really quickly with an example. So notice I have a resource. The constructor says created. Op1 says op1. Op2 says op2. And there's the finalize method. The finalize method they wrote as automatic garbage collection. And in Java, you have automatic garbage collection, as you know. But unfortunately, automatic garbage collection is automatic, but not instantaneous. In fact, garbage collection in Java is like the garbage collection in my neighborhood. I can put the trash out, doesn't mean anything. They can take it out anytime they want to. And if I call them and say, I left the trash out, they say, thanks for letting us know. And they don't do anything about it. Why not? Because they're like, we have got other important things to do than collect your garbage. Well, garbage collection can take any time to run, not right away. The problem with this is, if I say resource right here, a resource, let's say create an object, is equal to new resource, and I create an object, resource.op1, and I created the object like so. But if I run the code right now, what does it do? It says created. What was that? Did it pop up? Okay. So it says created, it says op1, but why was not finalize called? The finalize was not called because the garbage collector says, I got a lot of memory. Why waste time collecting garbage right now? But here's the problem. They, by mistake, brought two things together that doesn't belong. One is memory management. Of course, you want to manage memory. But the other is resource management. Your connections to databases, your connection to remote services. Those two are not the same. Java can manage memory, but who manages resources? That's our problem still, because they don't have the intelligence to know what to do. They took care of memory management, but the flaw was writing the finalize method. And guess what? This was done in Java 1.0. But in Java 9, what did they do? They finally deprecated the finalize method. But why? It took them that long to realize this was a bad idea. And we all do this over and over and over in our code. We bring two concerns that don't belong together and put them together. Rich Hickey talks about this. He calls this complecting. I call it entwinement. That's an English word. Complecting is not an English word. That's a word he made up. Complecting, he says, things is the source of complexity, he says. He nailed it. Finalize is a great example of complecting or entwinement. But look at your own code, where you brought things that don't belong together into one place. And in the long term, it hurts us more than benefit us. That idea of separation of concern that we all know about is so hard to follow in reality, but we should. So I talked about a few things here. I hope that's useful. There are too many moving parts in applications. Invisible changes that we often deal with. Uncontrolled mutability, lack of cohesion, excessive dependencies, technology infatuation, and low-level concurrency, imperative style versus functional style, and entwinement. These are just examples of things I have seen in my life so far among clients and projects I worked on where we ended up with enormous complexity because we had one or more of these things. I'm sure you have more things you have identified over time. But the beauty of these is when you identify them and document them and write them down and review it, we can review these, and if we can avoid these, we can reduce some complexity and move towards agility. And every day we put the effort towards that is worth, because in the end, we struggle to develop maintainable code. And I'll leave you with one thought. I think you will appreciate that. And that is, we should learn to deal with complexity, but have the wisdom to minimize it. Because if we don't, it becomes really, really hard for us to create applications that are maintainable. And in the end, a maintainable code is a gift we give ourselves for the future. And it's worth more than any other gift I think we can give ourselves. Hope that was useful. Thank you for your time.